Data is everywhere and comes in different shapes and volumes. These data need to be stored and managed using appropriate data management or database technologies. Think about the storage and retrieval of traditional numeric and alphanumeric data in an application developed to keep track of the number of products in stock. For each product, the product number, product name, and available quantity needs to be stored. Replenishment orders need to be issued as soon as the quantity drops below the safety limit. Every replenishment order has an order number, order date, supplier number, supplier name, and a set of product numbers, names, and quantities. Database technology is not just for traditional numeric and alphanumeric data. It can also store multimedia data such as pictures, audio, or video. As an example, YouTube or Spotify support the querying of music based upon artist, album, genre, playlist, or record label. Biometric data, including fingerprints and retina scans, are often used for security, such as border control as you enter a country. Similar information is gathered by wearables, such as a Fitbit or an Apple Watch, that continuously monitor and analyze your health and fitness. Geographical information (GIS) applications such as Google Maps store and retrieve all types of spatial or geographical data. Database technology can also store and retrieve volatile data. A popular example is high-frequency trading, where automated algorithmic platforms are used by investment banks or hedge funds to process a large number of orders at extremely high speed based upon events happening in the environment or macroeconomy. Also think about sensors monitoring the key parameters of a nuclear reactor, whereby an automatic system shutdown may be decided if certain thresholds are hit. You may have heard of the term big data, referring to the huge amounts of data being gathered by companies. Consider the data collected and analyzed by Google, Facebook, and Twitter daily. For example, look at Walmart, America's largest retailer with over 11,000 locations worldwide, $4.8 billion in annual sales, and over 100 million customers per week. Its point-of-sale database system stores an enormous amount of data reflecting which customer bought what products, in what quantities, at which location, and what time. All this data can then be intelligently analyzed using analytical data modeling to unveil unknown, yet interesting purchase patterns, such as which products are frequently purchased together. Better still, certain analysis techniques allow for making predictions about the future, such as which customers are most likely to respond positively to a promotion. These are just a few examples of database applications, and many others can be thought of. We briefly introduced the concept of a database by exploring the various types of databases you may encounter every day. A database can be defined as a collection of related data items within a specific business process or problem setting. Consider a purchase order system, where you have data items such as products, suppliers, and purchase orders. Each data item has characteristics. A product has a product number, product name, and product color. A supplier has a supplier name and a supplier address. A purchase order has a purchase order number and purchase order date. These data items are also related. A product can be supplied by one or more suppliers. A purchase order is always connected to exactly one supplier. A supplier can supply one or more products. These are examples of relationships between the data items that should be adequately captured by a database. A database has a target group of users and applications. Think about an inventory manager who uses our purchase order system to manage the inventory and issue purchase orders. Or consider a product manager who uses it for monitoring trends in product sales. A database management system, DBMS, is the software package used to define, create, use, and maintain a database. It typically consists of several software modules, each with their specific functionality. Popular DBMS vendors are Oracle, Microsoft, and IBM, whereas MySQL is a well-known open-source DBMS. The combination of a DBMS and a database is then often called a database system.